Okay, so this is going to be your guide to using J Clust2, and I'll cover the general usage of the GUI and how you can start viewing your spikes, clustering your spikes, and editing your clusters. So the first thing you want to do is you want to make sure you're in the path where you have J Clust2 stored, and you want to just go to your command window and just type in the command J Clust2, and this will launch the main GUI. Okay, to start loading your data, just want to go to the Load Data drop-down menu. You have three options here. You can load your raw signal, you can load your filter signal, or you can load your pre-detected spike waveforms. So for the purpose of this GUI, I'll show you quickly the raw signal, and that is located there's a sample raw signal located in the sample data here. There's also here the pre-detected spike waveforms that you guys can play with. For a number of reasons noted in the manual, the raw signal is the preferred option for loading your spike data here. And there's also, please refer to the notes on the sample data when you're playing with this. So we'll go straight to the raw data here. This is a 1 tetrode worth of raw data, about 6 minutes of recording time. And so we'll open this here, and we'll get a prompt to input information from our recording system. Because I already know these values here, I'll just fill them in. Okay, and so now what we get is we get a little prompt that shows that J Clust is filtering our signal, and the reason we want to use the raw signal briefly is just because it uses adaptive filter building and uses an FRI filter. So you get a really clean filtering of the signal. That's not always the case in online acquisition systems, which can distort the filtering of your signal because they use IR filter settings. So now we're done, and now we can start viewing our spikes, and we just want to upload the entirety of our data set. So I know this is about 6 minutes worth, so I'll just make sure I get all of it. You can put in over the time that you have in your recording session, and what you'll get here is this little warning that tells you that the last recorded sample is indeed at 360 seconds. So then J Clust loads spike waveforms, calculates the features, and it displays them in the main GUI. Okay, so from here what we can do is we can set epochs. So the first epoch we might want to set is the entirety of our recording session, just for example. So what this prompt allows you to do is set the currently displayed time as your current epoch. So we'll set this as epoch 1, and maybe we want to only view the first, let's say the first 3 minutes of a recording session. Say we noticed we had some notes from our recording session that said we had a particular bursty unit during that time, and so we want to pay attention to this particular time frame in our recording session. So we'll reset the time here. It'll load, and now we can save this as epoch 2. And now what we can do is, while we're clustering, we can switch between our epochs. So this would be our entire 6-minute recording session, and then we can quickly go back to those 3 minutes we might want to look at. Okay, the rest of the drop-down menus here are pretty self-explanatory. They control just the visualizations that you see in these plots. So this drop-down menu here controls the channel combinations. So start with 1, 2, 3, 1, 2, 4. So it just controls every possible 2D and 3D channel combination. Similarly, this lets you scroll through features. So we're in peak amplitude feature space to start with. We can go to crest to trough. You can see the power of the signal of each spike waveform, and PCA scores, and concatenated PCA scores. Another quick cool thing that you can do in J Clust2 is you can actually change the principal component you want to look at if you're looking at your spikes in a PC space. So in this drop-down menu here, we can select the principal component we want to look at, and essentially these 4 plots will give us the principal component we've selected here, the shape of that principal component and the variance that PC accounts for within that channel. So again, it's pretty self-explanatory, and this gets handy in case you want to select something that's not maybe one of the first two or the first three principal components, but also resembles an AP shape, an actual potential shape, and that principal component, even though it might account for low variance, it might tell you something useful about your data when you view your PC scores with that principal component. But for now, we'll just select the first PC. We'll confirm here, and when we go back to PCA scores, we'll see that we're in this first principal component space. Okay, so now let's start playing with clustering. Just to give you a quick, easy run-through of everything you can do to edit these clusters manually, I'll just run fuzzy c-means here, and I'll just choose a cluster size of 5. So this will cluster multi-unit activity as well as the other clusters. So we can see here that fuzzy c-means is kind of dirty. There's not obvious clusters, or there's some clusters that we wouldn't assume are units. Also, another thing to note here is that sometimes in MATLAB's 3D space, the way the plot function works is that you don't always see, if you're plotting multiple colors, you don't always see multiple colors at once if you're viewing them in a 3D space. I don't know the reason for this. You always do see them if you're viewing them in a 2D feature space. So we'll go back to one of the channel combinations. It's just a 2D, and we'll start editing our clusters here. So some classic things you can do are, first maybe we'll just delete anything that's not a clear cluster. So these two here are clearly not clear clusters. They clearly belong to the MUA. So what we'll do is we'll go 1, 5, we'll delete them. Okay, so now they go to the background noise. Another thing you can do is manually edit clusters. So fuzzy c-means will cluster every single spike in your data set when we know that some are clearly noise spikes. So we can select this 2D poly tool here, select the feature plot, this is the time scatter plot here, and we can start drawing a polygon around the points that we want to remove from our cluster. So we'll do something like this. Okay, and then you right-click to close the polygon, enter to select those points, and now we can remove these points from this cluster. And now maybe we go back and we say maybe we want to add this extra point back here. You can also add and remove points with the brush tool. So we'll select this point here, I'll add it back to the cluster, and boom, it's added. Lastly, you can merge two clusters. So I know we don't want to merge these two clusters here if we're actually sorting, but just to show you what this looks like, they'll merge into one cluster, and now you can see how also the cluster table is updated. So we might say, this isn't really a cluster, again, let's delete this. And then to get a better sense of our true unit cluster, even though we might have some extras here, we might want to hide all the background noise spikes. So just go here, we'll go hide spikes, and we can see our cluster here. Okay, and one last thing with the feature plot that I didn't go over is J Clust2 actually has some hotkeys built in, so you can easily change the feature you're viewing and the channel combination you're viewing them in without selecting this drop-down menu. So instead of selecting this drop-down menu, I'll instead use the arrow pads to change the feature space and the channel combination. So I just want to make sure that nothing is selected in the toolbar before I start doing this. And now I'll start scrolling through the channel combinations here. And I'm using the right arrow key to do this. To scroll back through to the left, I can use the left arrow key. Similarly, with the feature space, I can go up to scroll through the feature spaces, or I can go down to scroll through the feature spaces. And likewise with the time plot, so this is all the spikes in a particular feature space over time, I can use the number pad to scroll through feature spaces and channels. So here I'm using the number pad, I'm pressing 6 to scroll through the features, which is the right arrow key in the number pad, and I'm pressing 4 now to scroll through to the left. which is the left arrow key on the arrow pad. And again, I can go up on the number pad rather, and I can go down on the number pad to scroll through these different the different features here. Okay. So that's all the basic steps to using the GUI. One last quick thing to note here is that all your spike information is contained in this cluster info table. And again, this will change depending on what epoch you're in. So right now we're in the shorter epoch, epoch 2. It shows that we have 2003 total spikes and 189 spikes in our cluster. Let's just go to a different feature space to see it clearly. And then what we can do is if we change back to epoch 1, this will automatically update. Okay, so there you have your basic introduction to using J Clust2, and some following videos will go over using some of the other clustering algorithms here. So I'll show you how to use J Clust2 to manually cluster your spikes in a 3D space, and also what I think is my favorite clustering algorithm is running optics to cluster your spikes. I'll show you what that's all about in a separate video, and then I'll also go over utilizing these metrics here to really ensure you have great cluster quality, or great unit quality rather, after you've sorted your spikes. And from there I'll show you how to essentially use the metrics to quality clean your clusters and get great units, and then go over saving these units to the workspace in MATLAB.